So friends, we are passing through the last experiment on the topic of protection of transmission line using overcurrent and earth fault relays, and some experiments on simple power system, which are very important. There are many experiments which we are yet going to pass through, but we have to complete the theory first. So once we complete the generator protection, we will see some experiments on generator protection, which can be done in laboratory. Similarly, induction motor protection, CT, PT, etc. So here, as far as this topic is concerned, this is the last experiment. And very important, the experiment is on three-phase four-wire system. And to understand why the terminating system, that is the point where power terminates. Power terminates at a load point. Power terminates at your house, my house. Power terminates in shops. Power terminates in big buildings. Power terminates in industries, for 15-volt industries. So these points from distribution transformer, from PMT as we call, pole mounted transformer, to the last point. The power is distributed by three-phase four-wire system. Four-wire means fourth wire is physically run from distribution transformer to your house, to industry, to big building, wherever. You see, to the last endpoint, the power is, fourth wire is physically run. If that fourth wire is not physically run, what would happen? Equipment would be damaged. So we cannot do an experiment on damage to the equipment, but we can certainly do an experiment to show to you that yes, that voltage has increased badly. So this can be shown, and if you see by your eyes, you will believe, and once you will believe, you will never forget, because you have seen by your eyes, you have done the experiment of your own, right? So a very important experiment we are going to do. Motivation, I told that if the fourth wire is not run, the voltage of R, Y, and B phases would be variable, would be different. The lowest voltage can go to as low as 160, and highest voltage can go as high as 260. Instead of 240 or 230, 260, the equipment would be damaged because of high voltage. And because of 160 also, the equipment can be damaged. Which equipment can be damaged? Particularly induction motor would be damaged, because you see, while the motor is running, if the voltage is low, mechanical power is constant, therefore electrical input is also constant. Vi cos phi is constant, out of V increases, therefore V decreases, therefore I has to increase, right? So that damages the induction motor. If some tube light is there which needs minimum voltage to remain enlightened, to remain lighted, you see, if the voltage decreases, the tube light would not light, you see, and you would be in dark in that particular room. So such things can happen. Discomforts and damages can occur to the equipment, and therefore the standard allows the voltage plus or minus 6% from 240. More than that is harmful, right? So why this can happen, that we would like to see. So before seeing the procedure in different parts, we have to see the figure. Therefore, we will see which figure we are using. You see, we are using this very simple figure. Very simple in terms of connection also, and very simple in terms of money also, because we need 4 voltmeters and 2 ammeters. We need one-way simple switch which we are using in our houses, because there is no current passage. You see, 5 ampere switch is enough. Current is not the criteria. Our main point is the voltages are not remaining constant. That is what we want to observe. Right. Now this 0 to 2 ampere voltmeters would be, you have not to purchase, would always be available in any electrical engineering department laboratory. Voltmeters would be available. Simple switch is available everywhere, you see. And this 110 ohm, 2.3 ampere. And you see, rheostat may not be 110 ohm. If you got three rheostat of 185 ohm, that would also be all right. Main point is, all these things are usually available in laboratory and you can do the experiment at no cost. You have to connect the rheostats in a variable version so that you can vary the current. Because our main point is we want to see the effect of unbalanced currents on the voltage. Now we will see why the current can be unbalanced. Current can be unbalanced. It's not like so that current can be unbalanced. Current is always unbalanced. Because last distribution point is a society. In my society, there are 100 houses. If I am keeping my light on in my one room, I have to say my neighbor that you also keep in one room on. Third person also should keep one room lighted. If I keep all rooms lighted, all the room society members should keep them lighted. If I keep one fan on, everybody should keep one fan on. This is just not possible. It depends upon everybody's comfort. And therefore, the load is always unbalanced. It is not so that load has to be kept unbalanced. Load is always unbalanced. And therefore, in distribution system, load can never be balanced. In transmission system, it can be balanced. When at generating point, it can be balanced. But at distribution point, it is always unbalanced. And we would want to see what is the effect of this unbalance. And if we want to avoid that effect, mal effect of that unbalance, we have to connect the neutral of the system, neutral of the distribution transformer, physically to be connected with neutral of the load. Neutral should go continuously, physically, everywhere, in every house, in every industry. It has to be run, right? You might have seen on distribution towers also, the distribution poles also, that there are 4 wires, RYB and neutral. 4 wires are there. But we would want to do the experiment if neutral is not connected, then what would happen? And for that we have kept a switch in the neutral. So if you disconnect the switch, then neutral is not there. It's as good as neutral is not there. 3 meters to measure the current in 3 phases. Neutral meter to current the to measure the current in neutral. And you can have 3 voltmeters also, but if you want to save money, you can have 1 voltmeter and a voltmeter selector switch, which would measure here VY and VB. VN has to be measured separately because it would be comparatively small. And therefore, you see, a bigger voltmeter may not be able to read the small voltage accurately. And therefore, a separate voltmeter, VN, to measure the voltage between neutral of the system and neutral of the load. Very simple figure, right? So with this, we will see that we would want to go for 4 cases. The first case is neutral is connected, three-phase four-wire system, and load is load is balanced, which is not the case, which is never the case. But fictitiously we will do that case. Then we will take neutral is connected, but load is unbalanced. Then the damage is avoided. So we'll see why the damage is avoided. Then the third case is load is balanced, but neutral is not connected. Three-phase, three-wire system, but load is balanced, which is not reality. Right? Load is never balanced like that. But if it is balanced, then what will happen? And lastly, what is really happening is load is imbalanced and neutral is not connected. Reality means load is imbalance is a reality, but neutral is always connected to avoid the damage to the equipment. So with that we will pass through all procedures. The first procedure is keep the load switch on to keep the fourth wire on. Mains, switch on the mains, adjust balance currents by variable rheostats, right? Using variable rheostats, see to it that all currents are equal. Because all currents are equal, VR, VY, VB are equal. Because VR is equal to IR into RR. That is RR, RY and IB I have kept same. VY is equal to IY into RY, right? So like that, if you see all the three voltages have to same. Other way telling, if you draw a vector diagram, VR, VY and VB star, and then join all the ends of the star, then it will form a delta. So delta and star, you will see that neutral at neutral point, and it is at 0 point. VR, VY and VB are equal, no problem, right? This is the case, which is just an ideal. This never happens. This case does not take place. This never happens. Then we keep load balanced but neutral isolated, which is also not reality. Neutral is never isolated. Neutral is connected and load can never be balanced. But if so, then yet we are, because RR, RY and RB are equal, therefore VR, VY and VB are equal. And if you draw a delta, right, your neutral point is even at the same point. Neutral point is not changed, has not changed. And because it has not changed, there is no current passing from load of the neutral to system neutral. And therefore yet VR, VY, VB are equal. A fictitious case. Never happens like that. Now unbalanced load, but star point is connected. That is what we are doing. Load is always unbalanced. Because load is unbalanced, what is happen? IR, IY, IB are not equal. Therefore, IR plus IY plus IB is equal to IN. Some neutral current passes. Not only that neutral current is passing, that neutral is not at the same place. It has displaced. It has floated. Therefore, the name floating star point. Star point floats. It goes from one point to another. And therefore the current passes from the neutral of the load to neutral of the star, right? That is happening because you're not you connect you connected the neutral, the neutral current is passing. But what happens? That if you draw the delta, your neutral is displaced, and therefore VR, VY and VB are not equal. One can be 160 or 150 volt and another can be 260 or 270 volt. The phase where the voltage is 260 volt, that those equipment will be damaged, will just smash. A very costly TV, a very costly refrigerator, very costly things in your houses will be damaged, will smash. You have to purchase new. Second thing is all the important items in commercial buildings or shops or offices or whatever. And in small industries also, the it is industry is composed of equipment only, so all those electrical equipment will be damaged. And you may say that why under voltage? Because of under voltage also the equipment will be damaged. Particularly induction motor will be damaged because it was taking some power. It is taking the same power yet because mechanical power does not change. V I cos phi is the same. And because V has reduced, I has to increase. And increased current will damage the induction motor. Right. Therefore, low voltage also would damage. The normal lights, the filament lamps, no problem. It will light little, light तो कम हो जाएगी, but light will not go off. But tube lights, arc lamps, that light will go away. Therefore, you will be under discomfort. So, unbalanced load does these things, right? If you want to avoid that, what we do is unbalanced load, but star point is connected. When you connect the star point, right? When you connect the star point cannot float. It is fixed at one point. It cannot go anywhere away. And therefore, VR is equal to VY equal to VB. IR, IY, IB are not equal. That is true. But that extra current will pass through neutral, but neutral cannot float, and therefore VY, VB are equal, and therefore it is protected. This you will be doing by your own. You will be wiring and you will be taking the readings, and you will rather by taking the readings you will see by your eye. You will see by your eye the increase in voltage, and therefore you will not forget this any day. And if someday the equipment is damaged, you will obviously doubt the neutral wire, that probably that wire has been open circuited somewhere, right? So then from that day you will start, rather, you will start knowing the problem also and the remedy to problem also, right? So that is what the engineer is required for. Problems are there and he has to find out the cause of the problem and remedy of the problem. That is what for it is required. And it comes from the theory only. But theory you should have properly studied. The circuit diagram we have seen that first. And that, as I told you, we end with the sentence. So here also, today also we'll end with the sentence. You don't have to be great to start. Starting say, pehle hi din se. You cannot be Narendra Modi on the first day you are born. Or when you are 5 years old, you are not Narendra Modi. You cannot be Barack Obama. You cannot be a big saint on the very first day. But you have to start to be great. Great होना है तो start होना जरूरी है. I want to go to Delhi from Ahmedabad and I go somewhere or out of my house and stand there. Don't move at all. Then I will never reach Delhi. If I start walking, then maybe after 1 month, maybe after 6 months, whatever time according to my speed, but I will certainly reach Delhi because I have started. Because I have started. Right? A person was going somewhere. He stopped. He was not knowing where the place where he had to go. So he asked the another person that I want to go to a particular place. Within what time will I reach there? How far it is from here? So what will be the time taken by me to reach there? The other person was wise. He replied that you will never reach. You will take infinite time. You will never reach that place. So the other person felt that he is a mad. Person always reaches. Then, thinking that he is mad, he started walking. So that man replied that you will reach within half an hour because you are going to right direction, and that in this direction only the place is there where you want to go, and you will reach within half hour. So the other person asked, why did you reply so late? You should have replied earlier. You should have replied me there at that time only. Why did you not reply? The fellow said that I did not reply because you are not walking. If you are not walking, where is the question of reaching? Because now you have started walking and seeing your speed, I come to know that within half an hour you will reach that place. For going anywhere, you have to start. For becoming a big person, you have to start acting today itself. The sentence spoken by a philosopher, Ziegler, a very good sentence. With that, as always I say, I love, I adore the product which is developed by my sons, Adapt Me. I love Adapt Me because it gives me a chance to talk to you. It gives me a chance to meet you all, and it gives me a chance to teach you. So I hope you should also love Adapt Me. You should also remember Adapt Me, that it gives you a chance to learn important things. And not only that you should love, but you should share. You should tell to as many technical friends as you can tell that yes, here is a new thing that has come up and it teaches you many things. And you please go through that. Right? So go through this and read, uh, hear it as many times as you like, as many times as you feel like hearing, so that the name of Adapt Me reaches every corner of the world. Thank you, friends. Goodbye.